Hello everyone, myself M. Vaishali, a PhD student from CSIR Central Leather Research Institute. Today I am going to talk about my work on circular recovery of polymeric footwear waste from separation to sustainable upcycling. Imagine going to a footwear shop to buy a pair of footwear. You use those footwear for a couple of months and finally dispose them off in the bins. But have you ever wondered what happens to the footwear after you dispose them? Majority of the footwear goes and ends up into the landfill sites. Worldwide, less than 5% of footwear is actually being recycled, and this is a huge concern because the production and consumption of footwear has been tremendously increasing over the past few years. Now, this is mainly due to the change in consumer behavior. Earlier, every person used to own just a pair or two pairs of footwear, but today's fashion trend demands use of different types of footwear for different occasions. Well, we often worry about the fate of the footwear after we throw them away, that is the post-consumer footwear waste. But what we rarely notice is the waste that is being generated within the footwear manufacturing centers itself, which is called the pre-consumer footwear waste or the cutting waste. One of the leading footwear manufacturing companies in India provides a data that their company roughly produces around 45 tons of cutting waste per day, which roughly accounts to around 13,500 tons a year. Now, if you have 10 such manufacturing hubs all over India, it is going to be around 1.35 lakh tons of cutting waste per year that is being disposed of into the landfill sites. Now, this cutting waste or the pre-consumer waste has a very high potential for recycling as it is clean, sorted and devoid of any chemical contamination. Thus, my PhD work focuses on the recovery and recycling of the polymeric materials found in the footwear manufacturing centers and converting them into value-added chemical. Thus, to begin my recycling journey, I start by deconstructing the multi-layered polymeric materials into single-stream polymers to increase the efficiency of recycling, which is done through a chemical approach. The second challenge that we resolve in our work is the extraction of dyes and pigments from polyester fabrics found in footwear. Deep-eutectic solvent, a class of green solvent, is used to strip the dyes from the polyester fabric. The dye-stripped fabrics are further upcycled into value-added chemical. The third challenge that we resolve is the polyurethane recycling. Polyurethane is used in different forms in footwear such as foam, elastane, coating, etc. Thus, in our work, we perform a controlled aminolysis process to convert polyurethane into functionalized urethane oligomers at a temperature of around 130 degrees Celsius. The functionalized urethane oligomers are further upcycled into waterborne polyurethane emulsion by replacing 50% of the virgin polyol, thus closing the loop of PU recycling. While the polyester fabric after the dye stripping process is converted into terephthalic acid, a chemical of known relevance to the industry with a purity of around 92%. The deep eutectic solvent after the dye stripping process is again recovered through activated carbon treatment with a purity of around 95%. Thus, to conclude, our approach offers an economic and sustainable solution to convert the complex footwear material into value-added chemicals. Thank you.